If you are new here, do not forget to like, subscribe and turn on the notification bell. Today we are going to learn about binary tree travels in order, per order and post order. Let's start. So what is travel? It just means visiting. Imagine every circle in this tree is a house. Travel is just the plan you make to visit every house exactly once. You do not want to miss any and you do not want to go to the same house twice. What is a binary tree travels? A binary tree travels means visiting every nodes of the binary tree exactly once in a specific order. Since a binary tree has a root node, a right child and left child, the order in which we visit those nodes changes based on the traverse time. There are three types of travels in a binary tree. They are in-order travels, per-order travels and post-order travels. Now let's learn each travels step by step. First we are going to learn about per-order travels. Now let's look at our example 3 to see the boss method in action. Remember our rule. Root is first, then the left side and the right side. We are start at the very top. Who is the main boss? It is A. We visit A first. Now the rule says go to left. We move down to B. Since B is the boss of its own little team, we visit B next. From B, we go to left again. We find D. D is also a boss. So we visit D. From D, we go left one more time to find G. There is nothing below G. So we visit it and move back up. We just visit the left side of the D. So now we go to the right side of D. We find H. Visit H. Now the D's team is done. We go back to the B and look at the right side. We find E, then visit E. The whole left side of the main boss of A is finished. Now we finally move to the right side of A. We find C, then visit C. Finally from C, we look left, nothing there, and then right, we find F, then visit F. The final part is A, B, D, G, H, E, C, F. First we talk about the common applications of per-order travels. First one is copying a tree. This is the best way to create a duplicate or clone of a tree, because you visit the root first to create it before adding the children. Second one is prefix expression. In maths, per order is used to write equation in prefix or Polish notation, where the operations like addition or multiplication come before the numbers. Third one is directory structures, used when displaying files or folders, as you need to see the folder name root before seeing the files inside. Now let's move on and understanding in-order travels. Now let's look at the 𝗕𝗶𝗵𝗃 method, also known as in-order travels. Our rule is here is visit the left side first, then the root and finally the right side. It's like reading a map, far left to the far right. We start at the top at A, but the rule says left first. So we go to B, then down to D and finally go to G. There are no more houses to the left of G. So we visit the G first. Now we move back up from the left child to its parent, that is D. We visit the D house now. After visiting the parents, we check the right side. We find H, then we visit H. Now the whole D team is finished. We move back up to their boss B, since we already finished everything on B's left side. We now visit B. Next we look at the right side of B. We finish E, then visit E. Look at that. The entire left half of the tree is done. Now we finally visit the main root at the very top, which is A. Now we go into the right side of A and find C. Remember the rule. Check the left side of the C first. There is nothing there, so we visit the root C immediately. Finally, we go to the right of the C and find F. Then visit F. The final order is G, D, H, B, E, A, C, F. In order like a flattening machine, if you pushed all the houses down to the ground, they would land in this exact order from left to right. Now let's talk about the common applications of in-order traversal. First one is sorting data. If you use in-order on a binary searching tree, it will give you all the data in perfect sorted order from smallest to large. Second one is infix expression. This is how humans read maths equations. It puts the operations in between the numbers like 3 plus 5. Third one is validation. Used to check if a tree is a validate binary search tree by searching if the resulting list is sorted. Finally, let's look at the cleanup method or post-order traversal. Our rule is visit the left side, then right side, and the roots says for the every end. It's like finishing all your small tasks before the finishing the big project. We start at the top at A, but we cannot visit the boss yet. We go down to B, then D, and finally go to G. G has no children, so we visit the G first. We move back up to the D, but the rule says children first. So we must visit the right side of D. Before we visit D, we finish H and visit H. Now that both children of D visited, we finally visit their parents of D. We move back up to B, but wait, B has the right child E. We must visit the child first. So we go to E and visit E. Now that the entire left and right team of B are finished, we can finally visit B. We look back at the main boss A, but we still have a whole right side to finish. We move to C. Before visiting C, we check its children. We find F on the right side and visit F. Now the C's children finished, we visit the parent C. Finally, every single houses in the tree is finished. Now we visit the very top root A at the very end. Final order is G, H, D, E, B, F, C, A. In post order, the main root of the entire tree will always be the very last letter in your list. We move back. Let's talk about the common application of post traversal. First one is deleting tree. This is a safe way to delete a tree. You delete the children first, so you not lose the connection of them, and then you delete the parent. Second one is postfix expression, used by calculators and computers to solve the maths problem using postfix or reverse Polish notation. Third one is space calculation, used to find the total size of directory. You must find the size of all subfolders first, before you can calculate the size of the main folder. To remember this is easily, just look at where the root is in per order, in post order and in order. In per order, root is at the start. In order, root is in the middle. Post order, root is at the end. So this is simple idea helps you to remember all the three travels very easily. That's all for today. I hope you understand it well. We will meet again in the next video. Thank you for watching.